Hello everyone, this is Manish from Skillable India. In today's session of geometric dimensioning and tolerancing, we are going to learn about the feature control frame. Okay, this is the very important part because in each and every engineering drawing, wherever we are specifying the for the machinist or for the manufacturing department, we are going to use the GD&T symbols. Okay, so while using GD&T symbol, we cannot use like this. So for that, we have to use this feature control frame. Okay, so this feature control frame is very important topic in GD&T. Now we are going to start. Okay, uh, so first of all, in this session, I am going to give you a detail of how to place geometric dimensioning and tolerancing symbols into the engineering drawing. Okay, so the feature in the feature control frame, the definition. Okay, so feature control frame or FCF is a rectangular graphics that represent specified dimensions information for one or more features. Okay, it usually appears on a blueprint or an engineering drawing or a CAD file. Okay, to define the tolerance specification for a specific dimension type. So the feature control frame is a rectangular box that is particularly divided in multiple compartments. Okay, within which geometric characteristic symbols, geometric characteristic symbol, tolerance value, modifiers, and datum references are placed. Okay, so the datum references are placed. So in this example, so this is the example for the feature control frame. So whenever we see, so this is the feature control frame. Okay, so this is one of the example we are taking. So in this there are multiple compartments you can see in this. And why it is important, because whenever we provide the tolerance geometric tolerance value, we will provide into this geometric feature in this feature control frame. So first of all, before starting this geometric first compartment, so this is the first compartment. First compartment is always provided, always given for the geometric characteristic symbol. So out of 14 symbol, any one symbol will be in the first compartment always. Okay, so you can use any of the 14 geometric characteristic symbols. So this is the first. Okay, so geometric tolerance characteristics. Okay, so first compartment is given for the out of 14 geometric characteristic symbol is placed in this feature control frame. Okay, it can be straightness, flatness, circularity, cylindricity. Okay, all these total 14 geometric characteristic out of 14, any of the geometric characteristics we can give into the first compartment. So this is the for the symbol of geometric characteristic. Okay, now this is in the second compartment. In the second compartment, it is first of all, this is for the tolerance zone. Okay, so second number, this is for the tolerance zone. So whatever tolerances we have to write, we will write over here to shape tolerance zone shape modifier. Okay, if we have not given any symbol in this, okay, so then it means that the tolerance zone can be if we are not provided any of the symbol, okay, like diameter. In second compartment, you can see tolerance zone shape modifier. When we give the symbol diameter, let's say we are using symbol diameter. Okay, this is the symbol of the diameter. Out of diameter, we can also use square. It means the tolerance zone is square shape. Okay, when if we are using out of this like this symbol, so it means we are the tolerance zone is in square shape. Okay, and if we are using s diameter, okay, out of this if we are using like this symbol, so it means the tolerance zone is in a spherical shape. Okay, so whatsoever we can use the symbol over here, so it just represent the tolerance shape. Okay, now if there is no shape modifier, it means if there is no modifier, okay, direct the tolerance value is written. Okay, what does this mean? If there is no shape modifier, if this is not available, let's say, so what does this means? It means that the tolerance zone is two parallel lines or two parallel planes. Okay, so diameter symbol is means the tolerance zone is in cylindrical form. If we are using diameter symbol, so it means the tolerance zone, which is the tolerance zone, so it is in cylindrical form. Okay, so that's why we are using the diameter symbol. Now, or we can give a you can see that in the second compartment only, in the second compartment only, the third position, so this is the third position. Okay, previously we are talking about second position, and first we have talked about the first compartment first position. Okay, so in the second compartment third position is given for the tolerance zone size. Okay, so this is the tolerance value, geometric tolerance value. Okay, so this is the geometric tolerance value. Whatever tolerance we are providing, we will write in the third position. Okay, so the numerical value given is the in the feature control frame is nothing but the tolerance zone size. Usually we call it as tolerance value or the geometric tolerance value. Okay, now we come up to the fourth position in the second compartment. Okay, so this is the fourth position in second compartment. In the second compartment, fourth position, material condition modifier, size modifiers. Okay, so in the fourth one we provide the modifiers. Okay, is used to modify the tolerance zone size. So to modify this tolerance zone, we use the modifiers. I will write down here, to modify the tolerance zone, we use modifiers. What does this modifier do? Okay, so we can apply the geometric tolerance to a regular feature of size only. Okay, so whenever we can apply geometric tolerance, we can only apply to a regular feature of size. Okay, so regular feature of size only we can provide the geometric tolerance value, regular feature of size. Okay, and we can modify the tolerance zone size also. So this size we can modify. How we can modify? By using modifiers. So by using modifier we get bonus tolerance. Okay, so this is how with the while using the modifiers we can use the bonus tolerance. Okay, so that's how it is called the modifiers. Okay, which can modify the size tolerances. Okay, what type of modifier we can use? We can use maximum material condition. So this is the symbol M we have used over here, you can see. So we can use the modifier maximum material condition. We can also use the modifier least material condition. If L shape, so here we can write down L and the round. Okay, so this is called the least material condition. Then we can use the projected tolerance zone. If we are using P means projected tolerance zone. Okay, we will in further sessions we will understand what is projected tolerance zone and how we can use into the engineering drawing and why we are using the projected tolerance zone. Okay, and some more topics like fixed fastener formula and another some more topics are there. Okay, so that is very important. So we are also using the projected tolerance zone. Then we are using the tangent plane. Okay, T in a circle, we use this symbol for the tangent plane. Statistical tolerance zone. So ST and circle with the inside the circle. So we use this for the statistical tolerance zone. Then we use F symbol round the circle, which is for the free state. Okay, so in the starting I have already told you about the free state, that why we use free state. Okay, so non-rigid parts we use the free state condition. Okay, like rubber o-rings or gaskets. Okay, so for those parts we use the free state condition. Okay, so modifier frequently used when the tolerance geometric control is applied on a regular feature of size only. Okay. So whenever we use the geometric control, which is applied to a regular feature of size. Okay. Apart from these, there are also uh, there are multiple modifier. Okay. So these all type of modifier we use into the fourth compartment. Okay. Now we move towards the third compartment and fifth position. Okay, so this is compartment is called the third compartment, and this position is called the fifth position. Okay, so whenever we use the feature control frame onto a form control, so whenever we use whenever we use feature control frame onto a form control. Okay, form control, then there only be I will say are two compartments. Okay, so only two compartments will be there whenever we will provide the feature geometric tolerance to a form control. Okay, in form control there are four characteristic symbol: straightness, flatness, circularity, and cylindricity. Okay, whenever we use the form control, only two compartments will be there: first compartment and second compartment. These three compartments will be not be there. Okay, but whenever we use the geometric tolerance to a related feature, okay, then we can have a minimum of three compartments. Like we can have three compartment, this compartment, this compartment, this compartment, and maximum of four compartments. Oh, in the sorry, five compartments in the feature control frame. Okay, so in the third compartment, always the primary datum. So this third compartment will be for the primary datum. Okay, so this third compartment is for the primary datum. And in the fifth position, this is the symbol for the primary datum. Right now we are using. Okay, so onto the drawing in the datum identification. So whenever there is a datum identification, let's say this is a part. Okay, so in this part, it is specified like this, that this surface is the datum A. Okay, so always this datum modifier is all datums are always provided onto the engineering drawing. Okay, so primary datum should be selected on a plane that contains feature that are critical to the function or inspection of the feature. Think mating surface. Okay, it must have at least 3 points or 3 degrees of freedom. Okay, of contact with the part which are not in a straight line, a plane to hold the part. Okay, so to fix the part onto the fixture, okay. So first of all, we already know the concept of the 6 degrees of freedom. If we don't know, in the coming sections, I will tell you that how 6 degrees of freedom works. And with the help of 6 degrees of freedom, we came to a part from free state to a we hold in such a way that with the help of 6 degrees of freedom, we hold or we lock all the 6 degrees of freedom, three rotational and three translational movements. Okay, so with the help of these, we lock all the 6 degrees of freedom to hold the part. Okay, to stop the part movement. Now, in the whenever a datum is considered, that would be the first reference for measurement. Okay, so datums are the, I will say datums are to be considered, that would be the first reference. Okay, so in the primary datum, these are the first reference for measurement. Okay, the order of the datum is important. Whatever the order. Okay, so these three compartments are for the primary datum, secondary datum, and tertiary datum. So order of precedence is very important. Order of precedence. We will understand this order of precedence in a detailed manner. Okay. So order, that primary datum, it will be the first, secondary datum will be second, and tertiary datum will be third. Okay, so the primary datum usually have three places to fix 3 degrees of freedom. Okay, so primary datum holds to fix 3 degrees of freedom, or three movements. It locks three movements, primary datum, to hold the part. Now we will move on to the concept of the boundary condition. Okay, so the sixth position in the third compartment, whenever the datum we consider is a regular feature of size. Okay, so this datum is a regular feature of size, then we can use the modifier over here. Okay, so in this case we can use maximum material boundary or the least material boundary modifier. Okay, so this M symbol you will see over here is maximum material boundary MMB or least material boundary. So the concept of maximum material boundary condition is very useful since it can allow much easier assembly conditions. Okay, as the datum feature departs from the MMB, its MMB, it can allow a shift so that the positional tolerance pass. Okay, when the regular feature of size is considered to be a datum, MMB or LMB modifier can be applied. Okay, so we can apply MMB, maximum material boundary or least material boundary modifier when the regular feature of size is considered to be a datum. Okay, whenever regular feature of size is considered to be a datum, we can use MMB or LMB modifier can be applied. Okay, if now we come into the seventh position. Okay, so this is the seventh position in the fourth compartment. If required, we can use the secondary datum. Okay, so this will on to the right of the primary datum in the fourth compartment. Okay, so again this letter correspond to the feature somewhere on the part on the engineering drawing. Okay, which will be marked with the same letter, which is B. In this case we are using B. So whenever symbol like this is given, okay, so it is denoted somewhere on the engineering drawing. So this letter denotes for the second datum. Okay, secondary datum, and this holds or fix 2 degrees of freedom. Okay, now finally we secondary datum should be perpendicular to the primary datum and have a minimum of 2 points or of contact or 2 degrees of freedom. Okay, line. The datums often establish the orientation of the second axis. Okay, so in the second compartment, it is for the secondary datum which is perpendicular, always perpendicular to the primary datum. Okay, and it holds minimum of 2 degrees of freedom. Now we have in the fifth compartment, we have the tertiary datum. Okay, so finally, in the fifth compartment, we have tertiary datum. If required, this would be at the fifth end of the fifth compartment. This letter again correspond to the feature somewhere onto the part, which will be marked by the letter C. Okay, so this is also denoted by letter C like this. Okay, so it is denoted somewhere onto the engineering drawing with the help of this mark. Okay, and this locks 1 degree, 1 point of contact or 1 degree of freedom. Okay, so tertiary datum should be perpendicular to both primary and secondary datum, and must have the only form 1 point of contact. Okay, so a point, a datum feature contact the third plane of the datum reference framework. Okay, so this is very important. So this is all for the feature control frame. Okay, in the next discussion, in this all the feature control frame we have already discussed. So these are the entities, or I will say items, that can be used in the feature control frame. Okay, in the second session we will use one example. Okay, so in the feature control frame, whenever we want to use the geometric tolerance onto the feature control feature, let's say whenever you want to use the geometric tolerance onto a feature. Okay, so this surface is considered to be a feature. This surface is considered to be a feature. Then the feature control frame leader. Okay, so then the feature control frame leader. Okay, so this leader, this is the leader we are using over here. Leader arrow directly pointing onto the surface of the object. Okay, so in this case, this is a form tolerance. Okay, straightness we are using over here. So in this compartment, whenever we use form tolerance, we have only two compartments. Okay, with the tolerance, geometric tolerance characteristic symbol and the geometric tolerance. Okay, so only two compartments we are here. So, or we can show it onto the extension line over here. Okay, whenever we want to use the geometric tolerance to a feature of size. Okay, whenever we want to use it as a feature of size, so what we do is then the feature control frame. So feature control frame, this is a feature control frame. Feature control frame leader line. Okay, leader arrow should be in line with the dimensional arrow like this. Okay, so this is a feature of size. This is a feature of size. Whenever this arrow is pointing towards the feature of size, just below dimension like this. So this is how we place the feature control frame onto a feature of size. Okay, both things are different. Whenever we are using like this, it is a feature, surface is a feature, and these dimensions are called the feature of size. Okay, regular feature of size, irregular feature of size we have already understand. If we talk about the regular feature of size, so anything we can measure with the help of vernier caliper, it comes under the feature of size, the regular feature of size. Okay, so just below dimension like this. Now in this example, you can see this is all about how to place geometric symbols in the engineering drawing. Okay, so this is how, this is the leader line, if you will say. So it is just placed between, so this is a regular feature of size. Okay, in the regular feature of size, we are using this dimensions like this. Okay, so this is the positional tolerance symbol, characteristic symbol we are using over here, positional tolerance. This is the tolerance, 0 0.1 is the tolerance. M under circle is the modifier, maximum material condition. This is a primary datum, secondary datum, and tertiary datum. Okay, so in this you can see that these are the symbols we are using over here. This is for the primary datum, this is for the secondary datum, and this is for the tertiary datum. Okay, so in this you can see that the planar datum, center plane, axis datum. Okay, so these are how we provide the tolerances to the uh, into the drawing. Okay, so always we provide the primary datum, secondary datum, and tertiary datum. This is for the hole and this is for the shaft. Okay, so this is how we use the feature control frame. Okay, so this is all about the feature control frame. In the next discussion of GD&T, we will discuss some other topic. Thank you everyone.